What if I told you the battery that claims 100,000 charge cycles, that promises to outlive your car, your house, maybe even you, might not be telling you the whole story? For months now, Donut Labs' solid-state battery has been called the holy grail of energy, zero degradation, extreme temperatures, insane cycle life, and a future where batteries simply never die. But in the battery world, when something sounds too perfect, engineers don't clap, they calculate. And when experts started calculating Donut Labs' claims, three uncomfortable truths began to surface, truths that aren't exactly false, but aren't clearly explained either. Tonight, we're breaking down three truths Donut Lab doesn't highlight, not with hype, not with hate, but with physics, data, and industry reality. And by the end of this video, you'll understand why solid-state batteries are revolutionary, but also why this revolution may be far more complicated than Donut Lab wants you to believe. Truth number one: 100,000 cycles does not mean what you think it may. ESs start with a headline number: 100,000 charge cycles. On paper, that sounds impossible. Most lithium-ion batteries degrade after 1,000 to 3,000 cycles. Even Tesla's best cells rarely exceed 5,000 full cycles under ideal conditions. So how does Donut Lab reach 100,000? Here's the first truth: not all cycles are equal. In battery science, a cycle doesn't always mean charging from 0% to 100%. Many companies quietly define a cycle as 10% gives 20%, or microcharging, or extremely shallow depth of discharge testing. 10 small partial charges can sometimes be counted as 10 cycles, even though they barely stress the battery. Donut Lab never clearly explains depth of discharge, C rate during testing, temperature control, or whether these are full equivalent cycles. On that matters a lot, because when you convert partial cycles into full equivalent cycles, that shocking 100,000 number can shrink dramatically. Still impressive, yes, but a mortal battery? Not quite. Why this isn't technically a lie, but still misleading. This is where marketing gets clever. Donut Labs' battery chemistry can survive extreme microcycling because solid electrolytes don't form dendrites, as easily mechanical. Stress is lower, thermal runaway risk is reduced, so yes, cycle life improves. But the real-world question remains unanswered. How many full 0 to 100% cycles at real-world power levels? And that number has not been independently verified. Truth number two: solid-state instant mass produzione. And here's a second truth no one talks about. A working prototype is not a scalable factory product. Donut Lab shows lab cells, test rigs, controlled demonstrations, but scaling solid-state batteries has crushed far bigger companies. Toyota, QuantumScape, Samsung, SDI. All of them discovered the same brutal reality: solid-state batteries behave very differently once you try to mass them. The manufacturing wall: solid electrolytes are brittle, sensitive to pressure, difficult to layer uniformly, extremely sensitive to microscopic defects. Even a hair-thin crack can kill performance, cause internal resistance spikes, or silently reduce lifespan. That's why most solid-state batteries work beautifully in labs, struggle in factories. Donut Lab has not yet shown a high-yield production line, cost per kilowatt-hour, or defect tolerance data. Without it, mass adoption remains theoretical, not guaranteed. Why this matters for EV vehicles: demand, vibration resistance, rapid charging, high current draw, thermal abuse tolerance. A battery that survives static lab testing can fail spectacularly in a moving vehicle. This is the reason why Tesla still refines lithium-ion, Toyota delays solid-state timelines, and startups avoid firm delivery dates. So when Donut Lab implies near-term deployment, engineers raise an eyebrow. Truth number three: energy density vs power density. Here's the most technical and most important truth. Donut Lab's batteries often praised for longevity, safety, stability, but what's discussed far less is power density. Because here's the uncomfortable fact: many solid-state batteries trade power output for longevity. Why power density matters: power density determines acceleration. In EVs, fast charging speed, peak load performance, a battery can last 100,000 cycles, but if it can't deliver high current without resistance buildup, it won't work for it. Performance EVs, heavy tracks, aviation, grid balancing at scale. Some solid-state chemistries survive forever but charge slowly and discharge cautiously. Lab hasn't publicly released iseric discharge curves, sustained fast charge data, thermal rise under extreme load. Without this, we don't know if the battery is a powerhouse or a marathon runner. Both are valuable but very different applications. The bigger picture: why Donut Lab still made it. Now let's be clear. None of this means Donut Lab is a scam, or that solid-state batteries are fake, or that the technology won't change the world. In fact, this is exactly how every major battery breakthrough begins. Early lithium-ion batteries were expensive, weak, unreliable. It took 30 years to reach today's level. Donut Lab may be standing at year 1, not year 30, and that's okay. What Donut Lab is doing, or let's give credit where it's due. Safer chemistry, reduced dendrite risks, insane theoretical longevity, high thermal stability. Modular design concepts, these are real innovations. The issue isn't the tech, it's the expectations. The real truth. Nahuten Oxide 1 tells YOU here's the biggest truth of all. There is no perfect battery, only trade-offs. Donut Lab didn't hide these truths maliciously. They simply focused on the best-case narrative, as every startup does. But understanding the full picture is what separates hype from reality. Solid-state batteries are coming. They will change energy forever. But the road there is longer, harder, and more complex than any press release will admit. So now I want to ask you, do you think Donut Lab is the next Tesla-level breakthrough? Or another solid-state dream still fighting physics? Drop your thoughts in the comments. If you enjoyed this deep dive, hit like, subscribe, and stay curious, because the future of energy is far more interesting than the headline suggests.